everyone, welcome back to my channel. What we learned in our previous classes, we learned about trigonometric definitions, trigonometric ratios of some specific angles, and about complementary angles. Yes, today we are going to learn a new topic about trigonometric identities. What is an identity? What is meant by identity? What is an identity? Identity means it is a mathematical equation which is true for all the values of variables in the equation. It means, see here for example, it is a equation. It is an equation. A plus b whole square is equal to a square plus b square plus 2ab. Yes, and it is also an identity. What's the definition means? If you are substituting the values of a and b in this equation, if it holds LHS is equal to RHS, then it is known as an identity. It is known as an identity. Okay. Now, for example, see here, what's the equation? Given equation a plus b whole square is equal to a square plus 2ab plus b square. Yes. Suppose the values of a and b are a is equal to 1 and b is equal to 3. What is LHS? LHS is a plus b whole square. Substitute the values here. What is a? 1. And what is b? 3. 1 plus 3 whole square. 1 plus 3 is 4. 4 square is 16. Yes. The value for LHS is 16. Okay. Next one is about RHS. A square plus 2ab plus b square. See. What's the value of a? 1. A square See here, a square plus 2ab plus b square. What is the value of a? 1. 1 square means always 1. And 2. What's the value of a? 1. And b value is 3. Next, b value is 3. Means b square means 3 square. What's the value of 3 square? 9. 1 plus 2 into 3, 6 plus 9. 9 plus 1 is 10 and 10 plus 6 is 16. See here. We proved that LHS is equal to RHS. The value of LHS 16. RHS is also 16. Yes. So, we showed that LHS is equal to RHS. Then it is an identity. What's the definition? It is a mathematical equation which is true for all the values of the variables in the equation. Means if you are giving any values, we are going to substitute these values in equation. If it holds LHS is equal to RHS, then it is known as an identity. Then what is about trigonometric identity? A plus b whole square is equal to a square plus b square plus 2ab. It is an identity. Yes. Then what is about trigonometric identity? Trigonometric identity means if these identity equations are having any trigonometric ratios of an angles, then it is known as trigonometric identity. What is trigonometric identity? An identity equation having trigonometric ratios of an angle, it is called trigonometric identities. Means an identity equation, those are having trigonometric ratios of an angle, then that is known as trigonometric identity. See, example is sine square theta plus cos square theta is equal to 1. This is a trigonometric identity. Before this, what I said, what is an identity means? What example of identity means? A plus b whole square is equal to a square plus b square plus 2ab. Yes, it is a identity. It is an identity. But this is a trigonometric identity because this is holding trigonometric ratios of an angle. Yes, these are holding trigonometric ratios. So, it is known as a trigonometric identity. Sine square theta plus cos square theta is equal to 1. So, in this class, we are going to derive a trigonometric identity. First, means we are going to prove that sine square theta plus cos square theta is equal to 1. Okay, we will derive this, and the remaining identities will be based on this. Okay, now let's start our class. Say this is trigonometric identity. Sine square theta plus cos square theta is equal to 1. Now we will derive a trigonometric identity and the remaining identities will be based on this method. To derive this trigonometric identity, first we need to draw a right angle triangle diagram. We need to draw a right angle triangle. See, our first identity is sine square theta plus cos square theta is equal to 1. Okay, from this we can write remaining identities. See here, if I transfer this cos square theta plus cos square theta to right side, then it can be interchanged as minus cos square theta. Yes, see here, sine square theta is equal to, I'm shifting this cos square theta to right side, and here plus can be changed as minus. 1 minus cos square theta. Okay, this is about sine square theta, and here sine is having square, sine square theta. Now I am removing this square, means I want to know the value of only sine theta, not sine square theta. This is about sine square theta. Next is about sine theta. Sine theta is, if we remove square from this side, then what will be resultant? That is under root of 1 minus cos square theta. Sin theta is equal to square root of 1 minus cos square theta, because I have shifted this square to right side. So square can be interchanged as square root of 1 minus cos square theta. See, this is the sin square theta plus cos square theta equal to 1. This is a trigonometric identity, and these are also an identity. These identities are based on this first identity. Sine, first what I have done here, I want to know the value of only sine square theta. I want to know the sine square theta, means what I have done here, I shifted this plus cos square theta to right side. It's changed as minus cos square theta. Sine square theta is equal to 1 minus cos square theta. Next, I removed square from this here. I transported to right side. That's right side. Then here square is interchanged as under root of 1 minus cos square theta. Sin theta is equal to square root of 1 minus cos square theta. And next one is, from this identity only, I am writing next identities. See here, cos square theta is equal to 1 minus sin square theta, because I am shifting this sin square theta to right side, and his plus is changed as minus. That is 1 minus sin square theta. This is about cos square theta. Cos square theta is equal to 1 minus sin square theta. Now remove this square from this side and write the identity on cos theta. That is, see here, cos theta is equal to square root of 1 minus sin square theta. Cos theta is equal to square root of 1 minus sin square theta. So these are the four identities that are based on this sin square theta plus cos square theta equal to 1, this identity. From this identity, we can write these four identities. Okay. So next identities. This is the next identity, that is based on secant square theta minus tan square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. See here, it can be written as secant square theta is equal to 1 plus tan square theta, because I have shifted this minus tan square theta to right side. So minus will be changed as plus. Secant square theta is equal to 1 plus tan square theta, and secant theta is equal to square root of 1 plus tan square theta. Okay, up to here clear? And next one is, see here, secant square theta minus tan square theta is equal to 1. Yes? See, what I am going to do means, just I am shifting this 1 to this side and tan square to right side. Okay, interchange 1 to here and shift tan square theta to right side. It can be written as secant square theta plus 1 will become as minus 1. Secant square theta minus 1 is equal to tan square theta. Mean, see here, secant square theta minus 1 is equal to tan square theta. means it is about tan square theta is equal to secant square theta minus 1, where tan theta is equal to square root of secant square theta minus 1. So these are the four identities that are based on this identity secant square theta minus tan square theta is equal to 1. Okay, these are the four identities that is based on this identity. And next is about cos and cosecant and cot. So this is the third identity. Cosecant square theta minus cot square theta is equal to 1. Okay. From this identity we are going to write remaining identities. Cosecant square theta is equal to 1 plus cot square theta. Mean we have shifted this minus cot square theta to right side, 1 plus cot square theta. Now cosecant theta is equal to square root of 1 plus cot square theta. Now next identity is just shift 1 to left side, that is cosecant square theta minus 1, and cot to right side. Minus cot can be written as plus cot minus cot square theta can be changed as plus cot square theta. Now cot square theta is equal to cosecant square theta minus 1, where cot theta is equal to square root of cosecant square theta minus 1. So these are the identities that are based on this identity. So what you have to do means you need to remember the three main identities. From these three main identities we can write the remaining identities. So what are those identities? Sin square theta plus cos square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. And the third one is cosecant square theta minus cot square theta is equal to 1. So if we remember these three identities, it will be very easy to write the remaining identities, because the remaining identities are based on those particular identities, isn't it? So what are the three identities? So these are the three main identities. If we remember these three main identities, it will be very easy to write the remaining identities. Okay. This one is about sin and cos, next is secant and tan, and next one is cosecant and cot. Sin square plus cos square equal to 1. Cosecant square theta minus tan square theta is equal to 1. Cosecant square theta minus cot square theta equal to 1. So at first we need to remember these three identities. Okay. So this is about today's class, and next class will be we are going to solve problems that are based on these trigonometric identities. Okay, up to then practice these identities and trigonometric ratios. Okay, thank you for watching my channel, and please subscribe to my channel.